All right, we're going to prove that this limit as x approaches 2 is 7. Let's start with the preliminary analysis. And this is just going to help us with the proof later on, but this is not required work for your solution. So you're going to start with taking x minus whatever it's approaching and put that in absolute values. Step 2, you're going to take the function minus the limit in absolute values. Then you're going to manipulate step 2 to look like step 1. So I'm going to collect like terms. And then I'm going to factor this so that I have an x minus 2. So this would be x plus 4 and x minus 2, because 4 times negative 2 is negative 8, and 4 plus negative 2 is positive 2. And then what you want to do, so this is a new step because in the linear problems you have a constant in front, but here we have another equation in front. So we're going to take the one we started with, always take the one you started with, and we're going to set that less than 1. So remember, we're trying to find a good delta, a good choice for delta, and that's what step 3 is. So we're going to start with 1. We don't have a delta yet, so we just want to pick a small number, and the easiest small number you can think of is probably 1. And that way we don't have to work with any weird decimals. So 1 is small enough. So we're going to say that this is less than 1. Now we're going to get rid of our absolute value by, so let's do this down here actually. So delta equals 1, and we have absolute value, it's less than 1. So we're going to get rid of our absolute value by doing negative 1 is less than x minus 2 is less than 1. So if you remember from algebra, you can drop those symbols by putting that expression between the positive and the negative. And then what I want to do is get x plus 4. So I'm going to have to add 6 to the middle in order to change it into x plus 4. But I'll have to do that to all 3 sides. And I get 7. And so I have x minus 2 is less than 1. And now I have x plus 4 is less than 7, and I can go ahead and put absolute value on that. So now I'm also going to have delta equals epsilon over 7. That's my new C that you saw in the linear problems. So that's my preliminary analysis. Now I'm going to actually do the proof, and this is the part that you would turn in. So we're going to start with given that epsilon is greater than 0, choose delta to equal the minimum value between 1 and epsilon over 7. So since we have 2 choices of delta, and remember when we have 2 different deltas, you always want delta to be the smallest of the 2. But we don't know what epsilon is, so we will never know which one is actually smaller. But whatever it is, we want to choose the smaller one. So that's how we start. Now we're going to have our if statement, which is step 1, x minus 2. So if the absolute value of x minus 2 is less than delta, then, well, now we're going to show this work that we had in step 3. So we're going to start with step 3 first. If x minus 2 is less than delta, and delta is possibly 1, then we're going to say that this is less than 1. And we said earlier, when that is less than 1, that we can split it. We could say so, and then we can add 6, so we would get this, which we already did this work before. So Okay, so we want to put that in the proof somewhere so that we have a statement for x minus 2, we have a statement for x plus 4. Now we're going to consider our then statement. Now consider step 2. And then we can go ahead and show the factored form for the work that we did during the preliminary analysis. And now we want to use some logic. So we want to go back to what we've stated and make a statement here. So let's start with what we just said. X plus 4 is less than 7. So if I have x plus 4 times x minus 2, and x plus 4 is less than 7, then this is less than 7 times x minus 2. If x minus 2, we said earlier, is less than delta, then we can say 7 times x minus 2 is less than 7 times delta. And if delta is one of these, and we want to get epsilon, we can choose delta to be the epsilon over 7. You can either put, let's put which equals 7 times epsilon over 7, and the 7's cancel, and so we have the function is less than epsilon. And then we can just, so that's what we wanted, and then we can just conclude by saying therefore, by definition, that limit exists. So that limit is true, and it equals 7.